Welcome back, everyone. In this portion of the lesson, we're going to be looking at geometric sequences, geometric series, the sum to infinity, as well as sigma sums. Let's have a look at the concept map. So guys, I'm going to be going over each of these concepts, defining them, and then later on we will be doing some examples. So let's just remind ourselves about what a geometric sequence is. This is a pattern where there is a common ratio between terms. So essentially, if I had the pattern 2, 4, 8, 16, I can see that each time I have multiplied the term by 2 in order to get to the next term. So when there is a common ratio between all of the terms, this is a geometric sequence. The nth term for a geometric sequence is Tn is equal to AR to the power of n minus 1. A reminder that A is the first term of the pattern and R is our common ratio. Please remember you can find your common ratio by taking a term value over the value of the term that comes before it. Let's look at the next slide. A geometric series is formed when the terms in a geometric sequence are added together. So please be careful. There is a difference between sequences and series. Series are an actual sum, whereas a sequence is a list of the values of a pattern. So below you can see the 3 plus -9 plus 27 plus -81 going on. We know that this is a series because there's actually addition involved. But please note it could actually be written as 3 minus 9 plus 27 minus 81. So a series may also just have negative values or negative signs rather in between, because those values are still being added together. Because when I add a negative value, it still is negative. Great, let's look at the next slide. When I'm calculating the sum of a geometric series, I can either use Sn is equal to A times 1 minus r to the power of n all over 1 minus r, or I can use Sn is equal to A times r to the power of n minus 1 all over r minus 1. Please remember that this is when the ratio is not equal to 1, as this will make it undefined. Great, so in order to actually calculate a geometric series, I need my A and I need my R. Cool, guys, so I hope that everyone is okay so far. We are now going to have a look at sigma notation. So please remember that as soon as you see that sigma sign, there is most likely series involved because it is involving addition. And I know that the summing of terms is often associated with series. So when I see a sigma, I need an alarm bell to go off in my head telling me that this is a series question. Let's go back to the board. So the sigma symbol is an instruction to determine the sum of a sequence. So that's the link to your series. The use of sigma in series gives us the opportunity to add any consecutive terms in a sequence and not only the first n terms. So I could hypothetically add from the 3rd term to the 10th term. I don't have to go from term 1 to term 10. I'm allowed for the first term of my sum to not be term 1. Let's go to the next slide. So the next part of geometric series is the sum to infinity. The sum to infinity applies when my common ratio is between -1 and 1, and the ratio is not equal to 0. So essentially, it's when it is a proper fraction. When the ratio is between -1 and 1, the terms of the sequence approach 0, and their sum approaches a finite number. Please note that the most commonly used word when we're talking about the ratio in sum to infinity is that the series or the pattern converges. The pattern converges when the ratio is between -1 and 1. The actual terms themselves get closer and closer to 0, and their sum gets closer and closer to one specific value. So in other words, the sum is converging, getting closer and closer to one value. Let's go back to the board. So we can calculate the sum to infinity for a geometric series using the formula below. But let's just quickly look at what's on this slide. It says we can calculate the sum of the entire series with infinite terms. So essentially we're saying that if I were to add every single value of this sequence together, I can actually come up with a number that will express the sum of an infinite amount of terms. I can do this because the series is moving towards one finite number. So if I were to add all of the terms together, they are going to get closer and closer to one specific number, and that specific number can be assumed to be the sum to infinity. So the sum to infinity can be calculated when I have A divided by 1 minus R. So I need my A and I need my R. Please remember, I can only use this formula if my ratio is between -1 and 1 and R is not equal to 0. So only use sum to infinity if your ratio meets the requirements. Great. So everybody, I hope that everyone's comfortable with the definitions of geometric sequences, geometric series, sigma sums, and the sum to infinity. After the break, we're going to dive into some examples. See you soon.